Hello everyone. Today I'm going to show you how we can solve beam by stiffness method. So in this example we have a beam and applied on distribution load by 15 kilonewton, and also we have a settlement on node 3 and node 4. This is node 3 and this is the node 4. So the first of all, we should go to make a global system. The global system is mean you take a moment and the force on horizontal and vertical. So in this beam, it's actually not in this beam. In general, all the beams cannot take horizontal force displacement, just only moment and vertical, not like a truss. Truss, we have only the two global system on horizontal and on vertical direction, but in the beam we have only moment and vertical. So first of all, give the global system, start with the part is can move. For example, here we start the moment and actually start with moment first and then force. So moment, give this this is this one, moment number 1, moment number 2, moment number 3, and the force is up to you. You can assign the force on the node number 1 or 2, is up to you, but here I make this one is 4, and then moment number 5, moment force 6, and force 7, force 8. You can, if you want to follow, depends on you, and would you like to each part give a number, is up to you, don't worry. And then cut the member for 3 parts. This is member number 1, member number 2, and this is member number 3, to make it easy for you when you solve. Second, and also give the direction from right to left or left to right, is up to you. Here we don't, it's make it easy when you want to find Linda, but here we have a beam, so no need to calculate the Linda X and Linda Y. This is only for the frame and the truss. In beam we don't use this, but just make it a direction, it's up to you. Second step, change each part to make it a fixed. So actually our beam is look like this. We have a fixed here we have fixed, and 3 rollers. So now after divided the beam for 3 parts, so the rolls should roll or hinge or bend up, is depend on the structure that you have. So change it to fixed. So here this is the fixed, this is member number 1, and also this is the fixed from both sides for member number 2, and this is the fixed for member number 3. Okay, as you see here in this part. Okay, then find the moment and the reactions depend on fixed end moment. So here for the is actually this, all of them same. So the moment, it will be load L square over 2, and this is for moment, and for the reaction it will be load time L, the length of member, divided by 2. This is for the reaction or force, up to you. It's actually for reaction. So that we during these equations we get the load is 60 kilonewton and the moment 80 kilonewton, and also this here 60 and 80 kilonewton, because it's the same length. Each length or each member has length. This is 8 meter and 8 meter and 8 meter, and same distribution load, so you will get the same values for this example. Then find what is the known and unknown forces that you want to help you in when you solve. So here actually for known forces we have only the moment number 1 and moment number 2 and moment number 3. Okay, because we have a rule, and actually this is a fixed. We have a moment here at not 1, but actually it's unknown forces. So the known forces is only when we have a hinge or we have a roller or bin, and the others forces is 0. Oh, sorry, the displacement. So when we take displacement noun, actually depend on the if we have settlement or no. So and take the vertical direction. Therefore, then D4. So here this is 1. The D4 on node 3 is 0. We don't have any settlement or any applied load or anything. For D5 actually is the M5. M5 is 0. We don't have moment on the node 1. Then D6, because it's the force, not moment, so I mentioned for it D. D6 is 0. D7 and D8. D7 we have a settlement by 45 millimeter. Sorry, it's very small. The PDF is not a good quality. So here we have a settlement and change the unit, so it will be 0.054, and also have a settlement at node or at force 8 here, depend on this question. Depend on example, we have 15 mm, so it will be 0.015 mm. This is the settlement, and these are the values of dk. Okay, then make your matrix depend on beam matrix. So in beam matrix, actually it's different from frame and truss. So just to show you, I hope it's clear. This is K noun, and this is the dk. So here these values actually for k noun, you can find it during the fixed end moment. So in this one, the 80 kilonewton from this one, this is the moment of M1. Okay, because we don't have others part, so we will get this only this this value. But because now in this node, this is the node number 2, sorry, actually it's number 3. This is node number 3. Number 3 we have is actually located between two members. So one direction is anti-clockwise and the others is with clockwise direction. So it will be the value is negative. This is the value is 80 kilonewton and this one is 80 kilonewton. So it will be 0 as you see here. This the value is 0. And then go to node number 2. Also we have same values and in different directions of moment. This is the 8 and this is the second 80. So 80 minus 80 it will be 0 here. So that the FK it's 80. This is for node 4 and this is for node 3 and this is node 2. So now go to the matrix of beam. This is the beam matrix. It's very easy. Just substitute the length of each member, and 12 EI and 6 EI, 4 EI is constant. Okay, this is for the K1 of member number 1. Just substitute the length and we get this matrix of member number 1. Okay, next slide, same, just substitute or make it for member number 2 and for member number 3. These are the value of matrix, and then collect the matrix of member 1, matrix member number 2 and matrix member number 3, and make it a big matrix. Here this is the matrix. Okay, and then find the unknown displacement. That's mean we have because actually this is our beam. It's the rolling. So for we have known this moment and this moment and this moment. That's mean however the displacement or the moment or rotation is unknown, so that I will divide this matrix for 4 parts. To find theta. Theta, I mentioned, I wrote theta 1, theta 2, theta 3, not d1, because we talk about moment. If we have a force or a vertical force, that means you mentioned by d, small d. So then find the theta 1 and theta 2 and theta 3 by equation or by your calculate or Excel. You will get the theta 1, theta 3 and theta 2. Then substitute in the general rule of F. This is the general rule. F equal K times D, and find for the unknown moment and unknown force, same part, just divide it your matrix and find it. So these the unknown forces. I want to find it, and this is the K21. This is K21. This is K11, K12, and K22. Okay. This is the values of theta. This is the mathematical way to find plus K22, and this is the values of D. Okay. Don't forget the settlement. Settlement should be minus, because settlement is pull the structure to down direction, so you should be put minus. And then find the values of F and moment, that unknown. Then add it with the matrix of these. All of these are matrix actually. It's unclear for you. Okay. Then when you want to draw the shear bending moment, shear and moment, actually add it with the values of you get it from fixed end moment, and you will get this drawing. This is for shear and this is for moment. Just take it to find the actual force that effect on this beam, and draw depends on that values. So thank you for kindly attention, and it's actually same ways you can solve the others, any structure, beam structure. And finally, thank you for kindly watching and listening, and see you in the next video. I will explain about the frame structure. Thank you.